Thank you. Hello, my name is Monika Glier. I'm a web developer working at Rebased, which is placed here in Warsaw. And today I would like to tell you about handling asynchronous actions in React Redux apps. As you probably know from the great invitation that guys recorded, I used to be a lawyer and switched to programming around 2 years ago. First working in Ruby, and since September working in React. To start with, I would like to tell you a few words about application that we're developing, because I think it's quite interesting. The application is used to manage thousands of solar power plants devices. And what is interesting is that the front end is written in React and the back end is written in C. And both application, front end and back end, are included into firmware which is placed on a controller, and then the controller serves a front-end application to engineers' devices like computers or tablets. So yeah, I think that's quite unusual, and it works more or less like internet router that most of you have at your home. When thinking of solar panel, most of people just imagine a simple panel that gains solar energy. But there is actually much more going on. The solar panels send us reports every day so that we can display some statistics about their condition. They also accept updates of configuration, and then they can also accept commands, for example, stow, unstow, and they also switch to night mode every evening. And after switching to night mode, when the night ends, they all joyfully inform us about sunrise, and they inform us that they are ready to operate. Okay, so switching to the subject of this presentation, when I was preparing, I was looking for definitions of asynchronous actions, and the most straightforward ones I found on our beloved source of advice, which is Stack Overflow. The first two definitions tell us that asynchronous actions are the ones that happen independently of the main program flow, so they happen outside of the direct control of the program. The third definition that I kind of like the most tells us that these are actions that happen when they happen, so not according to a predictable clock. We actually have no control over them. We can just initiate them and wait for the result, for success or for a failure. The most common example of asynchronous actions are HTTP requests. And let's take a look at how we would do asynchronous request in a simple React application. If we would like to fetch some data and just use it in a component, we could simply do it in component did mount lifecycle method. But the only thing we could do with such data is setting it on state of this component and maybe also passing it to its children. But usually we want to do a little bit more, and we want to manage whole application's store. That's where we usually use Redux. I don't know how many of you know React and Redux. Okay, quite a lot. That's great. So just a short introduction. What Redux gives us is one big application store that we can access from all components that are connected to this store. And how we work on data is that from component, we dispatch actions. We also have reducers that listen for these actions, and when these actions are dispatched, reducers update store accordingly, and then components that are connected to the store receive updated store and they re-render. So it goes on, and we dispatch actions, reducers update store, components re-render, and so on and so on. Okay, so if we want to perform asynchronous request, we usually use three types of actions in React applications. This is pending action, success action, and error action. Pending action is the one that we dispatch just before performing API call. And it usually, actions in Redux always have type. So the key type, which includes the name, of the action, and they usually include payload or other keys. So the pending actions usually only include ID or some simple data that we need to perform the request, and they usually set two additional attributes on state. That is fetching and fetched. Fetching set to true and fetched set to false allow us, for example, to display loading information to user. Then when the response comes, we are dispatching success action or error action. And success action usually includes JSON, and error action usually contains an error. They also usually set fetching to false and success action fetched to true and error action fetched to false. So we can display some data to user, or we can also display an error. But okay, these are simple actions, but they do not allow us yet to perform the request, because Redux itself only allows us to dispatch simple actions, simple objects. And to perform asynchronous request, we need to dispatch a function, for example, or to perform some other complicated logic. So that's where we need middlewares. And the most popular library for performing asynchronous requests in React Redux applications is redux-thunk. I think it's so popular mostly because there are many tutorials, and it's also mentioned in official Redux docs. Also, Dan Abramov, who's creator of Redux, shows examples of using redux-thunk in his tutorial. So this is a very popular library. The first slide shows the setup. I just wanted to show that it's really simple. The first two lines are the setup of Redux store, a simple Redux store. And the second part is how it looks to set up the store, including thunks. What we have to do is just to create thunk middleware and to pass it to our store creator. Okay, so let's take a look at example of asynchronous action creator that is responsible for performing asynchronous requests. As you can see, we do not return a simple object anymore. We return a function. And this function first dispatches our pending action, the config request, which passes ID. And then after performing API call, it dispatches success action on success and error action on error. It looks pretty simple, and it really is simple. So if you would like to start your adventure with asynchronous action, it's a good way to start. But let's take a look what would happen if we would like to include another promise. For example, perform some custom deserialization of received data. It starts to look a little bit like a callback hell. And yeah, it's a bit more complicated to read, and it's also a bit more complicated to test. Okay, now I would like to switch to second library, which is also very popular recently. It's redux-saga. As for setup, it's also very simple. We just have 6 lines in the second part, but we also simply create Saga middleware and pass it to store. And we also have to run root Saga that I will show you in a second. One interesting thing about Sagas is its name. The name comes from story. So Redux Sagas allow us to say asynchronous request as a synchronous story. So step by step, or chapter by chapter, paragraph by paragraph. Yeah, you can think of it like that. Okay, if we're working on sagas, we need to have 3 types of sagas. It's root saga that takes care of running all our sagas. It's WarsawJS, which watches for pending actions being dispatched. And these are worker sagas that I will show you in a second. As you can see, sagas use ECMAScript 6 generator functions. And they take all the logic and do everything for us. What we need to do is to dispatch from component the pending action. Then we have the WarsawJS that is listening for this action. And when the action is noticed, Saga runs asynchronous Saga for us, so the worker. Let's take a look at the worker. This is exactly the same action that we performed previously using redux-thunks. As you can see, it looks pretty simple. The code is shorter. And what redux-saga allows us to do is to assign a result of a promise to a variable. So here we can simply call API and assign the result to JSON. Saga stops performing, Saga suspend while the promise is being resolved, and they resume when the promise is resolved. So when the JSON is received, they resume performing and they switch to next step. So in line number 3, we call API, we wait for its result, and in line number 4, we dispatch success action. Okay, and how would Saga look if we would like to add the custom deserialization? It would actually still look pretty simple. We just added line number 4. We also wait for result of the deserialization, and we assign the result to config variable. Then we just pass it to success action. So the put method and the call method are Saga's methods, but they're really simple to use, and yeah, I think the code is clear. Okay, testing. When reading about Sagas and when reading about asynchronous actions in React, the most often mentioned advantage of Sagas is simple testing. And it really is simple. We don't need any external libraries. It's enough to use Sagas, and it's enough to use generator functions next method. So what we need to do is to create Saga and pass example config request action here. For example, action that includes ID 99, let's say. And then we only need to call next method on this Saga. When we call next method, we can then check if the effect is done and if effect value is equal to what we expect. So in the first test, we check if effect of running of the first step of Saga is equal to calling API with the method that we wanted to call. In the second test, we check in line 11 if the value of next step of Saga is equal to dispatching success action. What you can also notice in line 9 is that calling next method, we can pass expected result of previous Saga step. So that's why we don't need any mocking. We can simply pass arguments to next method. What if we want to test error response? We can do exactly the same. The only difference here is that we use throw method instead of next method. And that's how we tell Saga that we want to test an error. Okay, testing, thanks. Initially, I was planning to include tests here too, but I think they're much more complicated and it would take too much time. But I can tell you that for testing Redux, thanks, we need to include a bit more logic. We can, for example, use nock for mocking HTTP requests. We usually use redux mock store to mock redux store. And we can use store get actions method to verify which actions were dispatched. I also found example of testing redux-thunks with Sinan and its spy method that, for example, allows us to spy on dispatch methods and on actions that were dispatched. In the end of this presentation, I'm including links, so if any one of you would like to take a look, I encourage you. Okay, so to sum up, I think we can say that thunks are really simple and they're good enough for simple apps, and they're a good way to start our adventure with asynchronous actions and React Redux apps. What is a disadvantage is tough testing. As for Sagas, I think they provide better readability of complex actions and of complex tests. Great testability is the advantage. There are also many tutorials, and the only disadvantage, I think, is that it's quite a big new library to learn. OK, so why did I switch? Because actually in my application, I first used thunks as I followed tutorials, and then I switched to redux-sagas. So imagine a solar power plant, then imagine sandstorm, and then imagine that we didn't test our asynchronous actions well, and we need to tell our client that, oh, sorry, we forgot about a test, or we didn't do it properly. So the simplicity of testing was kind of tempting. OK, my private conclusions after switching from redux-thunks to redux-sagas is that sagas, as I was quite new to React, switching to sagas forced me to organize my code better. My action files then contained only simple action creators, and the whole async story was moved to sagas. Code became more readable. Asynchronous actions became simple stories to be read step by step. Testing is easier, faster, and cleaner, and I think it's more enjoyable. So I think I can also count on other people joining project that they will actually write the tests. What is a disadvantage is that every single person joining the project is asking where the whole async logic is, complains about having to make multiple changes, and is unamused about having to learn yet another library. Yeah, but I think I showed you that it's not that difficult, and sagas have many advanced features that allow us to make complicated flows, but it can also be used in simple projects with the just put and call method and simple tests. Here are the resources if you would like to take a look. And thank you. And see you next month at WarsawJS.
I see plenty of questions. I have also one, so I hope
I hope not so
manage.
cruel as previous ones.
I would like to ask about epics, because on the last Meetup.js we heard about forget about tanks, forget about sagas, just use epics.
Yes.
So if I'm someone who's comfortable with reactive programming, with the RxJS, should I even look at tanks or sagas? Because from what I've seen, it doesn't look so tempting.
Actually, you're asking about something that I've never worked in, because I'm working on React for the last 6 months, and my experience covers thanks, sagas, so
okay,
yeah.
Thank you.
Maybe in some time.
Okay, more questions?
No. Thanks for mentioning testability, but you also mentioned that sagas has great testability, and in my experience, it's totally opposite.
It's great what?
Has a great testability.
Testability, yeah.
Great sagas have great testability, and in my experience, it's totally opposite, because what saga test is in fact, according to like your example, and that's how docs teach you to do that. It's one giant mock. And imagine that you have a login action. Simple. Every one of us did that at least once. So you have two independent to each other actions, like saving a token, which comes from the response, and displaying an alert. And you have test for it. It's great. And now you're changing places of those two calls, and your test is useless. Because it's starting to failing, because you change the order in code of things which are totally irrelevant to each other. So I was working on the project with over 100 sagas, and it was a huge pain.
I can admit that when we are reading about sagas, this is one of the things that is quite often repeated, that the test only check if saga performs all the steps we want step by step. So if we change order, we need to update our tests. And yeah, that's totally true.
All right, any other questions? So there's also one question from me. Do you have any, did you notice any difference in performance?
No, I didn't notice any difference in performance, yeah. I think they both work pretty well.
Okay, so that's it. Thanks a lot.
Thank you.